Hey there, class. We're here today. What we are going to hope to accomplish today is to understand the idea of an open and closed system. When we take a look at any kind of system of particles, whether or not it's open or closed, can determine whether or not energy is conserved or whether there's non-conservative forces at work. So we're going to see if we can put these ideas together and consider this. So let's pop on over here and let's consider a pretty standard kind of system. What we have here is a mass of mass m. It is placed on some kind of spring, and this spring at its equilibrium position would look kind of like this. So the mass itself has fallen, and it has stretched the spring some distance x in that process. At the moment that we're looking at it, it does have a velocity in the downwards direction, and it is also accelerating downwards as well. So one of the first things to do when considering open and closed systems, we want to look at a free body diagram. A free body diagram is something we use to analyze the forces that act on it. If you need a little bit of refresher on that, you want to check out my video on how to draw free body diagrams and how to think through that kind of idea. So in this case, since we have a downwards acceleration, we know that the gravity force caused by the Earth is going to have to be larger than the spring force caused by the spring in the upwards direction. So these are the only two forces. We can ignore things like air resistance and any other forces that may occur. We're kind of keeping this to the simple case where it's just gravity and the spring force. So when we talk about a system, it really comes down to what do we define as the system. So let's start with the simplest system we can possibly think of, and that is simply the mass m. Our system contains just mass m. So ultimately our question here is it an open or closed system? And we're going to be kind of working through the ideas here to kind of answer that ultimate question. So let's remember, if we're considering just the mass m to be our system, then anything in the on-by notation, this being on and that being by, anything that is not m is actually external to our system. So if it's external, it actually is doing non-conservative work. So we have non-conservative work being done by the Earth. The Earth does non-conservative work, and the spring also does non-conservative work because, again, they're not contained in what we have defined as our system. So again, because there's non-conservative work being done by both of these, then these are being non-conserved. We have no other forces that we've considered acting on this system of M. So conservative work, there really is nothing done by any external agents, and everything pretty much would be internal to the mass itself. So this would be things like thermal energy and things like that. And again, generally speaking, when we're talking about mechanical systems, we really don't even consider these. So at this point, because all we have done is work by the Earth and spring, and they are external, that's going to tell us that this is an open system. It is not closed because we have external agents acting on our system. Now let's consider the same situation. Let's consider the same exact situation, but this time let's define our system as the mass and the Earth. So let's go back and rethink our free body diagram. If the mass and Earth are part of our system, then this force right here, the force of gravity, is in fact an internal force. So that is going to do conservative work. So conservative work is done by the Earth. Likewise, let's take a look at the other forces that act on it. We have here the force because of the spring. That's on the mass because of the spring. And the spring is not part of our system. Okay, the spring is not part of our system or not what we have defined. So it's not in there. So this would be non-conservative work being done by the spring. Okay, it's done by the spring. And therefore, because again, this is an external agent to our system, okay, our system only contains the mass and the earth, and the spring is external to that. This is also an open system. It is influenced by external forces, and therefore it is open to those external forces and their influences. Now, let's consider the same situation and let's redefine our system a third way. And by defining our system as the mass, the earth, and the spring all together, let's once again go back and ask ourselves, are we dealing with an open or a closed system? So once again, if my system is the mass, the spring, and the earth, we notice that all of the things that are involved with the forces acting on my mass are in fact, they're all internal forces. Therefore, the spring is conservative work. Okay? Within the system itself, it does internal work, or it's conservative work. The earth also is part of our system. Okay, it's the mass, the earth, and the spring. And so it is doing conservative work as well. We have no external agents. Okay, there's no external forces. So therefore, no external forces. Everything that acts on our system is within the system itself. And so therefore, we're considering this to be a closed system, because of the fact that all three of the things within our system are the only things that act on our system. So again, when it comes to looking at systems, how we define the system and how the questions we ask the questions determines whether or not a system is open or if it's closed.